Hi Chem Peeps. Today we're going to talk about dilution for solutions. So in the upper left corner you can see that I have some notes, and in these notes it explains dilution. So let's say we have a concentrated solution and I need to make a less concentrated solution from it. So I'm going to use the formula M initial times V initial equals M final times V final. Initial would be the more concentrated solution and the final would be the less concentrated solution. So here is an example. And M, capital M, stands for molarity and V stands for volume. And so if we look at the example that I already have solved here, it says if you need 500 milliliters of a 0.25 molar solution, but only have a 3.5 molar solution on hand, what is the dilution? So the 500 milliliters and the 0.25 is going to be our final values, and this 3.5 molar is our initial concentration. So you can see here I have 0.25 molar times the 500 milliliters equals 3.5 molar, and I don't know, this should be initial, sorry, this should be initial. I don't know my initial volume. So solving for that initial volume, I need 35.7 milliliters of that concentrated solution. Now remember, they want 500 milliliters. So in a flask, I'm going to put the 35.7 milliliters of the concentrated solution, and then I'm going to add the remaining, which happens to be 464.3 milliliters of water to make the 0.25 molar solution. Now, down here below, I have a picture of the process of making a solution. And the picture of the flask there is what we call a volumetric flask. And that is even better for making solutions and dilutions because they have a mark somewhere up here on the neck of the flask. It has a mark telling exactly how many milliliters to that mark when the meniscus comes up they have. And so if I wanted a 500 milliliter solution and this mark here was for 500, what I would do is I would insert my 35.7 milliliters of concentrate, and then I would add water to that line so that the meniscus rests on there, and that would be even more accurate. Now this is actually a picture. If you look here, it's not dilution, it's actually making a solution, and this is a common question that I've seen on AP exams and college chem exams about making a solution. So for example, let's say we want 500 milliliters of a solution, and let's say, just for giggles, I need 15 grams of the solute. The question is often asked, do I add, it doesn't want to write, question, do I add 500 milliliters to the 15 milliliters of water to the 15 grams of solute? And the answer is no, absolutely no. Because this 15 grams of solute is going to take up some of the volume of that 500. So this is a picture where I make my students explain what's going on. So in picture 1, I'm measuring out my solute and I have my volumetric flask. So let's just say it's 500 for our example, 500 milliliters. I tell my students to put their measured solute into the flask and then add water. And I tell them to add water about halfway. Dissolve it. Okay, so here we're dissolving what we do have of the solute in a portion of the water, and then fill the water the rest of the way to that calibrated line there. And it will be less than 500 milliliters of water, but the solution will be 500 milliliters. And the solution contains both the solute, which is the powder that I measured, and the solvent, which is the water. Okay, so let's look at a dilution question over here and solve it together, just so that we make sure we understand the problem that we are doing here with dilution. It says, how many milliliters of 11.1 molar nitric acid stock solution is needed or are needed to dilute to 0.500 liters in a 0.500 molar solution. So this right here is our final values. Right here is our initial concentration. So I'm going to take M initial, the pen doesn't want to write, and M initial times V initial, and set it equal to M final times V final. So my initial concentration is 11.1 molar. I do not know my initial volume. My final desire is to have 0.500 molar and 0.500 liters. So in this problem, my initial volume that I need when I solve for this is 0.0225 liters. Now, what does that mean as far as making it? Well, if I convert this to milliliters, I'm going to take 22.5 milliliters of the concentrated solution, and I'm going to add the difference in water, which is going to be 477.5 milliliters of water. Now, ideally, it would even be better to take this and put it in a 500 milliliter volumetric flask, and then just add water to that calibrated line with the meniscus. Okay, so I hope this helps you with dilution and solution making. I'm getting ready to dive into acid and bases, so check me out on TikTok and YouTube on sChemChats. Leave me a like, leave me a comment, and I'll see you in the next video.